Every day, more things are described as software-defined. This includes software-defined networks, software-defined radios, software-defined radar, and even software-defined vehicles. What do we mean when we say something is software-defined? All software needs hardware to run, so a software-defined radio still needs, well, a radio. What changes is the way the hardware works. In a software-defined radio, the hardware is more like a generic computer processor, though it still has some radio-specific parts. This makes it possible to use software to change what frequencies the radio uses, and even to dynamically tune the radio to amplify some signals and ignore others. So ultimately, when we say something is software-defined, we just mean that the hardware is built to be generic enough that we can use new software to change the behavior of the system. Why does this matter? Well, like we said before, when we deliver software, we're delivering electrons. It's a lot easier to ship and install a new software build than it is to install new radio hardware. This means it's easier to update our systems over time to add new capabilities and adapt to new missions. For our warfighters, that ability to adapt quickly to changing circumstances can be the difference between success and failure of their missions. At Lockheed Martin, the shift to software-defined systems means we're changing how we design and develop our systems. As we've seen, with software, it's better to build a little, test a little. Software-defined systems combine hardware and software development in a way that emphasizes the best approach for each. And our software, even the embedded software that drives our most complex systems, needs to have security and quality built in via our Lockheed Martin software factory. Next time, what's the best way to measure software?